right, today we're going to see how we can take derivatives of products and quotients. So before we saw that if you have two functions multiplying or dividing, we actually cannot take the derivative of each function and then just multiply those together. They don't work the same as your standard limits. That's because we're taking the limit of the difference quotient and not just the limit of each function. And if you try to evaluate that, it just will not simplify as derivative times derivative or derivative divided by derivative. So the question you have is, well, how do we do that? Well, first, our product rule. If you actually take that limit definition of the derivative and do some algebraic trickery, you will see that you can actually perform the following operations in this order. You could take derivative of the first one times the second function plus first function times derivative of the second function. Another more convenient way to write that would be f prime g plus fg prime. The g prime should be colored green there. Don't know what happened. Anyways, let's see how that works in practice. So here I have x to the 4 times sine of x. No possible way to rewrite that without a product of functions. So if I identify the first function factor and the second one, and use my power rule on that first one, and then the rule for sine on the second one, and then plug right into my formula f prime g plus fg prime. Looks like I get the following expansion here. And you could factor out some, x to certain powers. From here, though, I'm just looking that you can first just apply the formula for the product rule. Secondly, we have the quotient rule. So it looks almost identical to the product rule. Instead of adding, we're going to subtract, and we're also going to divide by the g squared. Also, don't know why that g prime isn't green here. Yeah, need to double check my settings. Anyways, take a close look at that formula. It's almost identical to the product rule. Let's see how that's going to work in practice. So here I've got x to the 1/2 over quadratic. No possible way to rewrite that without having some kind of product or quotient. So I'm going to identify the numerator function and the denominator function. Those are our f and g. And then we use power rules on both of those and then plug right into our formula, f prime g minus fg prime divided by g squared. So let's take a close look at that final answer, though. If you were to work this problem out of your book and then look in the back of the book and see what the answer they have is, likely they're going to have something like this. That's because our rule of thumb, no negative exponents in our answers and no complex fractions. So if you actually get common denominators and combine everything, you should end up with something like what I have below there. We should be comfortable doing that using all of those skills from pre-calculus. Okay, so I want to emphasize these are two important rules, but we want to avoid them as much as possible. Why is that? Well, because they have so many moving parts. The more processes in something, or I should say the more steps in some process involved, the likelihood of making a mistake somewhere is going to go up pretty high. So if you can avoid them, go ahead and do it. What do I mean by that? Well, if I take that example we just saw here, x to the 1/2 over that quadratic, if I was to look at the reciprocal, that would look something like this. This I can actually rewrite without having a quotient of functions using some properties of algebra. I can split that into two fractions and then use properties of exponents. Now, this is all algebra. Remember what we said in class, algebra first, calculus second. Here, I could just use my power rule. I haven't done any derivatives. I haven't done any limits. I just use algebra to rewrite it in such a way to make the calculus easier to do. Likewise, if I have a product, I don't always have to use the product rule. Here, I could actually just distribute in that x to the 4 and then use my power rule. You're probably seeing a common theme here. If I was to change one small part of my original function, if that was to the second, I could not just distribute the x to the 4. I could either FOIL out and then distribute, or I could use a product rule. I would actually probably use a product rule in that case. So avoid those rules when you can. Sometimes you cannot. How will you know when you can or cannot? Well, it just comes through a lot of practice and working lots of problems. The last thing I want to address real quick, higher order derivatives. This is just a rinse and repeat. So, we keep on keeping on with our derivatives. What I mean by that is if I see something like y double prime, All that means is I took the derivative of my derivative. And if I have y triple prime, I took the derivative of my derivative of my derivative. Meaning, after you perform one derivative, that doesn't mean you have to stop right there. We'll talk about what that tells us about a function, what the second derivative tells us, how that tells us things about the behavior of functions. But for now, just know that you can take more than one derivative. The sky's the limit. That should be enough for this video, and we'll get you started on those questions on Schoology.